I just want to thank you for that excellent talk. It was very interesting to see the work that you've been doing using biochar for the furfural conversions. And next, we will be moving on to our next speaker, who I will be introducing. So if you can move to the next slide. So Karen Michelle Coutiño Melchor is a student of the National Technology Institute of Mexico, Tuxtla Gutierrez campus. Apologies if I was incorrect, where she is currently attending the ninth semester of the chemical engineering degree. During her academic career, she has shown a deep interest in technological and sustainable development, standing out for her commitment and excellence. Currently, she is doing her professional residency in laboratory number 8 under the supervision of Dr. Rocío Meza Gordillo, focusing on the degradation of polyurethane foams, a project that reflects her interest in innovative and sustainable solutions. So I'll leave the floor for her.
Um, Good afternoon, everyone. Thank you for this opportunity. I like to say that if you could have a little consideration with me, because this is my first English presentation. My name is Michelle Coutiño Melchor, and I will present you my research work entitled Synthesis, Characterization, and UV Degradation of Polyurethane Foams Obtained from Used Vegetable Oil under the supervision of Master Eder Armando Caballero Moreno and Dr. Rocío Meza Gordillo. To begin with the problem addressed by this work is related to thermal insulation and foams of petrochemical origin and waste vegetable oil residues. In this sense, the main objective of this project was to contribute to the reduction of the pollution generated by both and provided a renewable solution to this waste. And in figure 1, we could see the process of converting the used oil into polyurethane foams. The image shows the different phases that we went through. First is the transformation of the oil into the polyurethane foam, followed by his top view of the foams before being exposed to the ultraviolet light, and then the comparison after the exposure. Also, we have as image illustrated the before and after process of collecting and purifying the oil used as a raw material. Then we have the synthesis process begins with the acid glycerols, which undergo an epoxidation process in which the double bonds react with peracetic acid and produce it in situ, using sulfuric acid as an acid catalyst, forming an epoxide group. These epoxides from the used vegetable oil are subjected in the same reaction system to a hydroxylation reaction or opening of the epoxide using water, generating the hydroxyl groups to obtain the polyol. Once the polyol is obtained, the hydroxyl groups react with the MDI dissocianate. In this reaction, the hydroxyl groups of the polyol bond with those of the isocyanate, resulting on the formation of the polyurethane foams. In the methodology, figure 2 shows the equipment used to evaluate the ultraviolet degradation of the foams, where the samples were subjected to ultraviolet radiation at 50 hours intervals with a maximum of 300 hours. The UV degradation was emitted by a LED operated in a wavelength of 375 nanometers. This ultraviolet was connected to this power supply that which we have this black plastic case for protection of the analyst. We have the other image with this scheme of the equipment used for thermal conductivity measurements, which is consists of two plates, a hot upper plate and a cold lower plate with water circulation. We have two heat flow sensors with thermocouples located between the plates, and the sample to be evaluated is between both of them. We have the initial data of the polyurethane foam, which shows a density of 80.35 kilograms per cubic meters and a thermal conductivity of 45.3, more or less 2.2 milliwatts under meter Kelvin. We have that the commercial foam have a density of 66.72 kilograms per cubic meter and a thermal conductivity of 31.9, more or less 2 milliwatts per meter Kelvin. In addition, is a microscope image of the polyurethane foam included, where the closed cells that make up its structure at the fiber is thermal resistance can be observed. And we have the ER spectra of the polyurethane foam by 0 hours of UV irradiation, when we can find those peaks. The first one in the wave number 3326 is we have the NH group, then we have the 1705, we have 1530 and 1220. Regarding the results related of the color of the foams, the present graph shows the progressive color change as a function of the ultraviolet irradiation time. This phenomenon correlates with the image 8, which is the process of the color change, and the characteristic yellowing of the samples over time can be observed. And then from a chemical point, the ultraviolet irradiation induces a reaction that activates the methylene groups, in turn promoting the activation of molecular oxygen. These two elements react, leading to oxidation and bond breaking of the methylene group, converting into a carbonyl group. In this image, we shows the mass change, and we can observe that the polyurethane foam presents a higher mass loss compared to the commercial foam. And this behavior is attributed to the polyurethane oxidation process, which affects more significantly to the foam derived from used vegetable oils. Then you have the figure 12, which shows the results of the thermal conductivity of the samples, where it's evident that there is a significant statistical difference between the commercial and the used vegetable oil foam before being irradiated with ultraviolet. There is a statistical difference between the commercial and this polyurethane foam, which there are no, this loss of mass together with the reduction of the thermal properties can be explained by the formation of volatile compounds during the degradation process. Then we have this spectra of the polyurethane foams at 0 and 300 hours of the UV radiation, which the results obtained of the infrared spectroscopy analysis reveal key changes in the chemical structure. And then, first of all, we have the breakage of the urethane bonds. Then we have the consumption of residual hydroxyl groups, the breakdown of free isocyanates and formation of ureas, and degradation of ester by photooxidation in the formation of hydroperoxides and carbonyls. These results confirm that the photooxidation process is a determining factor in the degradation of polyurethane, affecting both its chemical and physical properties. And then we have a conclusion that it said that the polyurethane foams synthesized from used vegetable oil exhibits properties suitable for thermal insulation properties. The degradation caused by the ultraviolet radiation in both the used vegetable oil polyurethane foam and the commercial foam leads to surface oxidation, resulting in a noticeable color change, weight loss, and in the case of the commercial foam, is a reduction in its thermal resistance. As in acknowledgement, of course, to the laboratory number 8 of the National Technological of Mexico, the National Laboratory of Housing and Sustainable Communities, from the Autonomous University of Chiapas, to the Engineer Jesus Alberto Flores Luna from the Mechatronics Lab, and Engineer Dylan Saúl Miguel Hernández. Thank you so much.
Thank you for sharing your wonderful work with us. Congratulations again on the poster prize. Now we're going to move into our breakout rooms. So we'll have a breakout room for both of our speakers separately, and also the Green Chemistry Connections breakout room as well. So feel free to join. They should be open soon. But if you have any troubles joining them, just contact one of us or message one of us through Zoom, and we can help you out. Yep, I think they're open right now.
Yep. Those are open now. Again, let me know if you need help. I'll be in the main room. Hello, everyone. I'm Chloe DuFlumeri. I'm Communications and Events Coordinator for Beyond Benign. You might get a lot of annoying emails from me. I'm sorry, that's just the name of the game. It's my job to annoy you. I'm kidding. So Green Chemistry Teaching and Learning Community, as always, this is our online place for everyone to connect, learn from one another, and grow. We have over 1,500 users from over 80 countries. So this is a really good place if you want to keep in touch with each other, to seek out. In the comments, we actually posted, or I actually posted a couple of times, a link to a forum in the GCTLC that is specifically for Green Chemistry Connections. So if you wanted to pop in there and introduce yourself, feel free to. It is your space. If you want to go to the next one. Yep. So we are continuing our Greener Curriculum Showcase series into January 2025, yay, and beyond. It will be on January 16th from 11 a.m. to 12:30 p.m. Eastern Time. This month, we will be introducing the case study module, Exploring Sustainable Practices in Metal Plating, the Drive for Greener Innovations. This was created in partnership with NYS P2I. So there's a nice QR code there. If you want to register, you'll get to walk through this teaching resource and learn how you could implement it in the future in your classrooms. We also are having our last Observe Wonder Think of 2024 tomorrow at 7 p.m. Eastern Time, with our very knowledgeable community member, Dr. Elizabeth Brown, who works for the Lab Safety Institute. She will be sharing with us the Lab Safety Institute's Safer Science Framework, which is designed to empower educators with the tools they need to create hazard-free, sustainable lab environments. So if you're teaching a chemistry lab, this one is relevant to you. So feel free to come out. Again, there's a registration code there. Scan that, sign up, and I'll be sending you the Zoom link sometime in the next 24 hours. And yes, we also have, once again, kind of sharing this for January 9th, 2025, the ASE annual conference, which will be hosted at the University of Nottingham. And just a couple more things here. I know we've got a lot going on. This is a ton of news, but we are starting our new webinar series for 2025. It will be 4 webinars. The first one, January 24th at 9 a.m. Eastern, 2 p.m. UTC. We will be hearing from Professor Ashley Haworth. She will be sharing about detoxifying chemical warfare agents to treating nuclear wastewater. These are the adventures in the synthesis of metal organic frameworks. So we're going to be looking at those broad applications on January 24th. So it'll be really exciting. We'll have another one coming up in February, and those details will be available soon. And once again, nice QR code if you want to register. Also, hope to see you at some of these spring conferences that are coming up, ACS Spring in San Diego, as well as the GCE conference in Pittsburgh. So really excited to see you all in person if you're able to join. And lastly, our final Green Chemistry Connections, oh my gosh, I forgot 2024. It's not in 2024, it's in 2025. It's not in December. It will be January 15th, 2025 from 6 to 8 p.m. Australian time. We will be hosting it on the other side of the planet from where we currently are as organizers. It will be on the topic of nanoscale and nanotechnology for green and sustainable chemistry and biomimicry. So if this isn't in your time zone, totally understand. It's not in mine. Once you register for the Green Chemistry Connections webinar series, as many of you already have, you will receive the link to the YouTube video recording that will be posted in a couple of days after the webinar. So feel free to share with your friends who might be interested. And lastly, thank you to all our supporters. Special shout out to ICL, who we missed at the beginning, unfortunately, in the slides. Millipore Sigma, you all make this possible, and we're so glad to be working with you. So special thank yous, and we're so excited to see you all in the new year. Thank you for joining us.
Thank you.
Thank you, everyone.